Hello everyone, I am Mockito. I will do a unit testing workshop in this video. Let's go through our outline and see what you will learn here. First, we will see the importance of unit testing. What is the real purpose of unit testing in a project? And then we will define what is unit testing. And then we will start practicing. We will prepare a Java project. After that, we will go through JUnit basics and write our first unit test. And then we will handle exception handling. After that, we will generate a code coverage report and see mocking with Mockito library. And we will compare integration testing with unit testing. And last, we will see best and worst practices for unit testing. So, what is the real purpose of unit testing? We can answer this question like this. It is to enable sustainable growth of the software project. As you can see from the graph, you can start fast without test, but when time passes, you start to make almost zero progress because you start to break legacy code and you are afraid of changing anything in your code base because you know it will break something. But with tests, you can provide a sustainable, long-lasting project growth. And if you are serious in software and you want to maintain your project for years, you had better to have tests on your code base. Another benefit of unit testing is detecting bugs as soon as possible because cost of fixing bugs increases exponentially as time goes. As you can see from the graph, the requirement phase is the best point in timeline to fix a bug. After that coding, after that testing, and the most expensive bugs are the ones on production. So, what is unit testing? Implementing automated tests that verify an atomic behavior of code in a quick and isolated way. The keywords atomic, quick, and isolated are important. We just test a unit of code and it should be run fast and it should be isolated from other dependencies and collaborators. And tests should be integrated into the development cycle, that is your build tool. Whenever you make any change, you need to be able to run your test from scratch. And your test should cover most critical parts of your code base. Apparently, some of your codes are more important than others and you may need to do some trade-off here. And don't forget, test codes are not second-class citizens. They should be as clean as possible, similar to production code, because you need to maintain them also. And another warning from Digextra. Program testing can be used to show the presence of bugs, but never to show their absence. That is, you cannot be 100% sure you handled all your bugs. Of course, we will target high coverage metrics, but even best metrics cannot prove we have not any bug remained on codebase. Let's do some practice. We will use JUnit 5 library. It consists of JUnit platform, JUnit Jupyter, and JUnit vintage artifacts. JUnit platform is the foundation. JUnit Jupyter is engine to write and run JUnit 5 based tests, And if you have a legacy code base that contains JUnit 3 or JUnit 4 based test, you need to add JUnit vintage. But in our examples, we will not use that. We will use Maven to grab dependencies, but of course you can use any other build tool, for example Gradle or Ant. We will use a simple Maven project with a quick start archetype. We will use Java 11. Let's continue with JUnit basics. In JUnit, we have some annotations that we put on our test methods. And the library provides us assert methods that we assert our expected values with the real results. For example, assert equals and assert throws. Let's start our Maven project. Choose Quick Start Archetype. Let's add some properties to make project compatible with Java 11. I will delete the default JUnit dependency and will add JUnit 5 dependencies. Search with JUnit 5 mail. But this is the only API artifact. I don't want to add all of them separately. I will add the aggregator to get all required artifacts. After a Maven update, we can see our artifacts are downloaded here. I will delete these all JUnit imports. Let's write our first JUnit 5 test method. Here is the test annotation import. We can run it with right click and run. So what about if we want to run this test with Maven test call? It didn't run it, so we have a problem. I will let an exception throw in test method to better understand if test is run or not. Because if it runs, it will fail. To resolve this problem, we need to add a Maven plugin, Maven Surefire plugin. I will get the latest version. We need to configure build and plugins part in POM XML file. After a Maven update, let's retry Maven test and see if method is run. Yes, there is a test failure, as we expected. That means our test is run and exception is thrown. Let's delete the exception part and rerun again. Yes, test has passed successfully. Let's review our POM.xml file. Let's practice other JUnit annotations with a classical example, calculator class example. I will add a sum, multiplier, and divider methods. Let's create our test class. I will add some test method here. I will apply arrange, act, and assert practice here. By this way, our test methods will be more readable and as a result, they will be more maintainable. In arrange part, we prepare our objects for test. In act part, we actually run our methods. And in assert part, we verify that our expected value is correct. If our expected value is not equal to the result we get from the X part, then our test will fail. Of course, we need to add the test annotation. Let's use other JUnit annotations before each, before all, and the others. We will have a problem. As you can see, JUnit wants from us to make before all and similarly after all methods to be static. These before all and after all methods run once when test file is executed. But before each and after each methods are run after and before each test method in the test class. As you can see from the outputs, before each and after each annotated methods run as we expected. Okay, let's see how we can test our exception handling codes. I will try to divide to 0 and get an exception. We will use a sort throws method to verify our exception. But first, let's see what will happen when we divide to 0. We get an arithmetic exception. Let's verify it and assert throws method. Let's rerun our method and see the test is passing. Yes, test has passed. And what if we define our own exception and we expect that exception to be thrown in assert throws statement? Yes, same result. Test has passed again. Let's continue with a not so trivial example. We will implement this domain model for a simulation application. We will have a base vehicle class and some subclasses of it. For example, car, sports car, truck, and minivan. And we will define a fuel usage service. And we will add some trivial methods in it, and we will use them in our test examples. First, I will add a vehicle type enum. Let's create our vehicle class. I will make it abstract. I will add some final attributes in it. For example, type, fuel efficiency. The values of them will come from subclasses, for example, car. Let's create getters and setters. I am defining subclasses. I am defining fuel usage service interface. Let's add a method to calculate approximate distance range with using remaining fuel in tank. Let's add an implementation class. Let's add some checks to detect any invalid value. Okay, let's add another method to calculate required fuel for a given kilometers. In the test class, I will initialize servers before each method execution. I will use calculator to detect our expected result. While working with double values, you need to be careful because precision can be problematic. Yes, our test has failed. Let's make our assert method more tolerable with adding a delta parameter. Yes, this time test has passed. Let's add another test for fuel current method. If we apply the given formula in calculator, we get the expected value. For the time being, I am copy pasting other vehicle type test cases. Let's test also exception handling part. We can also assert our exception message. Yes, it is done. Okay, I will continue with code coverage report generation. I will use JaCoCo plugin. We need to add a Maven plugin into our POM.xml file. Let's search JaCoCo. Go to the I want to use JaCoCo page. There is an example POM.xml file here and I will copy the plugin configuration. I am deleting the configuration part to simplify it. And I want to use the latest release version. After a Maven update, let's run JaCoCo report go. The report is not generated because there is no execution data. We need to run first Maven test. And yes, the report is generated. We have 86% code coverage until now. We can analyze classes here to see which lines are covered or not, or even which lines are covered partially. Let's continue with mocking. So why we need mocking? We need mocking to isolate our unit of code from its dependencies and collaborators. And also we need mocking to analyze interactions between objects. We will use Mockito library. The Mockito library enables us mock creation, verification, and stopping. And once created, a mock will remember all interactions. Then we can selectively verify whatever interactions we are interested in. As you can see from the example, a list instance is mocked and some methods are called, and at the end, the method calls are verified. Once stopped, the method will always return a stopped value, regardless of how many times it is called. And when you stop more than once, the last one is the most important one. And we have argument matchers. We may want to be sure that the method is called with correct values, or we don't care which value is used in parameters. And that is where we use argument matchers. As you can see in this example, we don't care the first two parameters values. We passed any integer, any string, but in the third parameter, we want the exact value. And here are the most important methods and annotations in Mockito. With mock, we can create mocks, and with when and given methods, we specify how a mock should behave. And we have spy. Spy is similar to mock. We can stop and verify interactions, but the difference is real methods are invoked. And with verify method, we check methods were called with given arguments. And these are the best practices of mocking. Do not mock types you don't own because we don't know the implementation details of them and they can change without our control. We can define value objects as immutable data objects and don't mock value objects because they will not change and they will not add much value into our tests. And don't mock everything because after some level we will lose our regression protection and the test will be worthless. And here are some references more to read. How to write good tests and Mockito documentation. Okay, let's make some practice. I will create a vehicle repository. I will not add implementation of this repository. I will use only for mocking. I'm adding a service class which calls these repository methods. I'm creating the test class. I will initialize service and repository instances before each method execution. And here is how we can create mocks with mock method. But of course, firstly, we need to add Mockito dependency into our POM.xml file. I'm creating a test to assert our save method in repository is called when we save through our vehicle service. I'm calling vehicle service save call method in act section, and after that I expect the repository save method is called also. And yes, our expectation is true. Let's see how we can run the same test with mock annotation. I'm adding mock annotation on top of our vehicle repository field, and we need to initialize annotations. We can initialize by two ways. Firstly, we will see Mockito annotation static method open mocks. Without it, our annotations will not be effective. As you can see, the vehicle repository remains null. But after we comment out it, the test has passed successfully. Let's see the other way of initializing annotations. We will use Mockito extension. But first we need to add that JUnit 5 Mockito extension artifact into our dependencies. Search for Mockito Jupyter artifact and copy paste that dependency definition into our POM.xml file. Let's rerun the test and see the test has passed. Let's create another test method to see how stopping is done. I'm configuring our mock instance vehicle repository that when find all cars is called, return this given cars list. And I am verifying the returned all cars list is the same list where we gave in when and then return line. Okay, I will continue with a spy test, but first I will introduce another service, a fuel provider service. In this service, we will fuel the fuel capacity of vehicles. And I will keep track of the statistics in a trip statistics data structure. I will create an implementation of this interface because I want the real methods to be invoked in Spice. And here how we can define Spice. We give the real implementation instance. Similar to mocks, spice can be used to analyze interactions of objects. And let's assert the real methods are called really. If we were use mock instead of spy, the real method will not be invoked. Let's see how static methods are mocked. I will create a util class and a trivial static method. We initialize a mocked static instance using mock static method, and we can configure and stop the static methods. As we can see from the implementation of the method, we normally don't expect any ID result when we give an empty input. But because of the mock configuration we gave at the above line, we will get what we want. Let's run the test and see the result. And done. Let's continue with comparing integration test to unit test. Integration tests means testing with other dependencies. For example, that dependency is usually database, and that means we are not anymore testing a unit of work but a bunch of other codes together. And it focuses on verifying components that work together. Integration tests are more expensive than unit tests because unit tests stand up and maintain dependencies, and test size increases because more components are involved. And here is the famous test pyramid for a typical software project. You have more unit tests comparing to integration tests and end-to-end tests. With integration test, you can get more protection to regression, but development and maintainability costs are greater than unit tests. On the other hand, unit tests are faster and smaller in size comparing to integration tests. Let's talk about best practices a little bit. Minimize assertions per test method. So then when test fails, you can easily understand why it has failed. If there are more than one assertions, you need to go to the code base and inspect what is the problem. For a similar reason, verify one use case per test method, otherwise test methods become complex and hard to maintain. Test boundary conditions, for example, null values, minimum and maximum values, empty lists, etc. Practice AAA pattern, arrange, act, and assert. By this way, your tests are more clean and readable, and as a result, they are more maintainable. Tests should be repeatable on every environment and they should be fast. Otherwise, developers tend to ignore them and they will not run them on each change they made. At least your software will be run and built on a build server. Your test should be run on there also. As I said in the beginning, high code coverage metrics will not solve all our problems, but we can and we need to target high code coverage, and by this way we can minimize our risks. And here are the don't do items. You should not need to test private methods or states. You should test observable behavior and end results. Because private methods are implementation details, they can change frequently. For a similar reason, don't make test too smart to calculate its expected values. Don't add codes just for testing purposes in production codebase because codes needs to be maintained and it will cost you much more than needed. Avoid logical conditions in test like if, while, for, etc. Tests should be precise and focused. When test failed, you should be easily understand why it has failed. You shouldn't be struggling to understand complex code base. And here we have come to the end. I hope this video is beneficial for you to understand basics of unit testing in Java. Don't forget to subscribe and give thumbs up. Thank you for watching.